In this lesson, I'll show you how to solve second-order differential equations. This is question number 1. The question reads, solve the equation y double prime is equal to 3 times cosine x, where x is in radians, if y prime is equal to 1 at the point 2 and 1. Before we start solving this, I'd like to replace y double prime with d bracket y prime over dx. Because differential equations are often written using the d operator that we first introduced when we started solving first-order differential equations. So whereas before we would change y prime into dy over dx, y double prime is changed into the following. That being said, d bracket y prime over dx is equal to 3 times cosine x. What we have to do is take the integral of this equation, but first we need to bring this dx over here, and we can do that easily by multiplying both sides by dx. And if we do that, we end up with dy prime is equal to 3 cosine x dx, taking the integral of the left side and the right side. Starting with the left side, we get y prime, and of the right side we end up with this 3 coming out, and the integral of cosine x is equal to sine x. Sine x plus c. Now to find this constant c, what we will do is substitute y prime with 1, and at the same time replace this x with 2. And remember, 2 is 2 radians. So we have 1 is equal to 3 times sine bracket 2 plus c. Bringing this expression over to the left side, we have 1 minus 3 sine 2 is equal to c. Make sure that your calculator is in radians. Currently ours is not. 1 minus 3 sine 2 gives us negative 1.72. c is equal to negative 1.72. So now our expression is y prime is equal to 3 sine x minus 1.72. Once again, I'll replace y prime with dy over dx. And on the right side, we have 3 times sine x minus 1.72. Multiplying both sides by dx cancels it out on the left side. Now taking the integral of both sides, if I take the integral of this side, I'll end up with y. And on the right side, if I take the integral of these two terms, this term becomes 3 times negative cosine, because the integral of sine x is negative cosine. I'll put that negative here, cosine x. The integral of this term is negative 1.72 x plus our arbitrary constant c. Now at the point 2 and 1, we can replace this with 1 and replace these x's with 2. Let's see what happens. We have 1 plus, I'm bringing this term over, notice that it's negative, bringing it over makes it positive, 3 cosine at 2 plus, notice the switch in the symbol here, 1.72 times 2. We end up with 3.19. c is equal to 3.19. So our solution to this question is y is equal to negative 3 cosine x minus 1.72x plus 3.19. To conclude, notice that we had to integrate twice to solve a second-order differential equation, and that 2 constants of integration have to be evaluated. And there you have it. That is how to solve second-order differential equations.